In this chapter, chapter 13, we didn't only talk about trig functions for right triangles and angles between 0 and 90 degrees. We also talked about trig functions of any angle. In order to talk about trig functions of any angle, we had to talk about the unit circle. And we kind of built some stepping stones in between talking about triangles and the unit circle. And the first kind of stepping stone that we talked about was converting between degrees and radians. And we learned that there's different ways to measure an angle. The one that we're most familiar with is degrees, but another way to measure an angle is with radians. So let's go ahead and do some conversions. We discovered that there are 180 degrees for every pi radians. Okay, and that's going to be important because in this problem here where I'm asked to convert 252 degrees to radians, I have to think of a conversion factor. So I have to think of a way to change 252 degrees to radians. Now I know I want to be left with radians in my final answer. So that means I'm going to have to cancel out degrees. So I'm going to set up my equation so that degrees will cancel, and I'm left with radians. So this is called a conversion factor. It's using the fact that there are pi radians for every 180 degrees to convert 252 degrees to radians. So let's see. What do I get? I get 252 pi over 180. All right, 252 over 180, that's going to reduce. 4 goes into 252 and 180, so I get this to reduce to 63 pi over 45 radians. Alright, now let's convert from radians to degrees. So this time, I'm starting with radians, and I have to think of a conversion factor that will have me end up with degrees. Okay? So I want to cancel radians. So I'm going to have to put pi radians in the denominator and 180 degrees in the numerator. So this looks similar to the problem above, but my conversion factor is flipped around. Okay. So in addition to my radians canceling, my pi's also cancel. When I do the multiplication here, I get 990 degrees. There we go. Alright, let's step it up a bit. In addition to talking about radians and degrees, we also talked about how you could have triangles positioned in the coordinate plane, and how the position of the triangle could be indicated by positive or negative x values and positive or negative y values, and how that affected sine, cosine, and tangent. So what I have here is I have a angle, and it's an angle in standard position, and the terminal side of the angle contains the point -4 and -3. And I'm asked to find the secant of this angle. So let's think about this for a second. So I have an angle and it's in standard position. So it's positioned in a coordinate system. And the initial side is always along the positive x-axis. So that's the initial side of my angle. The terminal side goes through the point -4 and -3. So 1, 2, 3, 4. The terminal side goes through this point right here, like this. And so I have this angle that I'm calling theta. Okay. Now the challenge was, how do I write a trigonometric function for an angle that obviously is bigger than 180 degrees, let alone bigger than 90 degrees. So the way I do it is I think of this as a triangle, and I draw a triangle that connects with the x-axis. And I know that because I have a position in the coordinate system, this side right here, this x side, is -4. And this y, this vertical distance is -3. And I could easily find the hypotenuse of this triangle. So let's do that. I'm going to use the Pythagorean theorem since this is a right triangle. And so I have -3 squared. Remember, it's the quantity -3 and the quantity -4. So I find that C is 5. And I still am not finished though. I want to find secant. Let's see. Secant is the reciprocal of cosine. So secant of theta is going to be hypotenuse over adjacent. So that's going to give me, I could also think of this as, instead of hypotenuse over adjacent, I could think of this as C over X. Okay, this is going to give me 5 over